this video, we'll be talking about our atmosphere. On page 14 of your Earth Science reference tables, you'll find this chart. This chart is the selected property of Earth's atmosphere. On the left, we have altitude above sea level. It has two different scales in kilometers and miles. The kilometer side is going up by tens, and the mile side is going up by fives. On the bottom, we have temperature, really only for the middle part of this graph. And then we have a pressure graph and a water vapor concentration graph. So it's important to know what you're looking at. Let's start with the troposphere, probably the most important layer that we'll talk about. The troposphere is the layer where all of our weather takes place, and that's really because of gravity. Gravity pulls all of the air down towards the Earth's surface, and therefore that's the densest layer, that's the thickest layer, that's where all our air pressure is. The temperature does decrease as we go up in the troposphere, but for the most part it is partly warm as you get closer to the surface. Also, all the way on the right for this table, there's a little chart for water vapor, and see how it connects to the troposphere? Our highest amount of water vapor is in the troposphere, and that makes sense because water also gets pulled towards Earth, and because it gets pulled towards Earth, it's going to be thickest in that bottom layer. So clouds, water vapor, like precipitation, really exists in the troposphere because of gravity. And one more thing, that pressure chart right in the middle, where it says 1, that's an atmosphere. That's a way to measure atmospheric conditions. And at sea level, the standard pressure is always 1 atmosphere. And as you go up from sea level into the sky, into the atmosphere, it decreases. Next, let's look at the stratosphere. The stratosphere ranges from 7.5 miles to 30 miles. It has a increasing temperature, which is really because of the ozone layer found at this point, and the ozone layer absorbs ultraviolet light, and because it absorbs that high intensity radiation, it warms up this layer dramatically. Above the stratosphere is the mesopause, and the mesopause has a decreasing temperature, and that decreasing temperature is really because there's so few air molecules in this area. Air really works as a blanket, layers of a blanket in the atmosphere, and at the mesosphere level there's so few air molecules that you don't have any way of retaining heat. Heat's really escaping very quickly from the Earth at this layer. And finally, the thermosphere, and we can see here the temperature is going way up, and that's generally because of direct radiation from the sun. So there's really no air here either, but because it's at the point being closest to the sun, as you get further and further up in that thermosphere, the temperature goes way up because you're getting direct radiation without anything to protect you. Nothing to filter out some of those harsh forms of high radiation from the sun. So that's why the temperature goes up. The layer that we'll concentrate on is the troposphere, because all of our weather takes place there. When we talk about the troposphere, we need to understand that it's not just made of one thing. It's not just air. It's actually a mixture of things. The biggest part of air is nitrogen gas, and nitrogen is about 78% of what we have out there in our atmosphere. And it's funny because human beings have no use for it. Most living things have no use for nitrogen, although it makes up the majority of our atmosphere and our air. Then you have oxygen. Obviously, we need that to breathe. And then there's argon at a very small amount. And then there's trace gases. And of those trace gases, you have gases such as neon, helium, methane, nitrous oxide, ozone, and then the biggest part of those trace gases, carbon dioxide. And carbon dioxide is really an important one to remember because that's partially where global warming and then climate change are said to come from, is the increase in that amount. So our air is really a mixture of different gases. In that air, we also have water vapor, and that chart in our reference table shows us that. The chart demonstrates that the troposphere has the most water vapor, and because of water vapor, we have clouds. Water vapor in the atmosphere is the source of all of our clouds and all of our precipitation. Water vapor gets into the atmosphere by this process, which is evaporation. So from all of the surfaces, lakes, and oceans, that water is evaporating as a natural process because of wind, because of temperature, because of pressure changes, and evaporates into the atmosphere to make clouds, to make precipitation. It's part of a cycle, a water cycle. Aerosols are liquid or solid particles suspended in the air. Those particles can be pollen grains, salt, bacteria, pollution, smoke, dust, and of course, gases from volcanic eruptions. And then that's really an important one because that's how our first atmosphere was created, from volcanic eruptions. In all cases, those aerosols, those tiny droplets that exist in our atmosphere that you can't see but are there, are how water droplets kind of stick to surfaces. They provide the opportunity for water droplets to collect, and when they collect, they get big enough, and if they get big enough, they become clouds, and if the clouds fill up with a lot of water vapor, that water vapor comes back down as rain. And that's really it. Water vapor needs aerosols in order to form these clouds, and then without these particles, there would really be nothing for water droplets to stick to. So it's an important part of our atmosphere. In addition to water vapor, aerosols also scatter sunlight. That's a form of, it's an interaction between electromagnetic energy and a surface. And when light is scattered, like it is here, we get blue light. That's what happens during the day. The sky looks blue because blue light's being scattered from aerosols in our atmosphere. And that color also changes when the sun sets or when the sun rises. The reddish color that's associated with that is because the sun is now at a lower angle than it used to be, and that produces a longer wavelength of light, and the longer the wavelength, the closer it is to the color red. It's that old Doppler effect again, and that mechanism is always happening every day. All right, so our skies are blue and our skies are red because of light scattering from the sun. So in addition to aerosols, we also have ozone. And now ozone is relegated, for the most part, to the stratosphere. That's where it should be, but that's not always where it is. So ozone is concentrated in the stratosphere, and that layer of O3, which is the chemical formula for ozone, absorbs UV light from the sun. It's a great thing. It keeps us safe. Without that ozone layer, life probably would not have evolved as it did. So it really kind of paved the way for Earth to be a planet filled with life. But ozone is also a pollutant. Sometimes it gets pushed down into the troposphere, or it's released from burning fossil fuels. Sometimes, and this is not a graphic from here, this is from Texas, but in areas where it gets very warm, there could be an air quality alert. And what that means is on very hot days, ozone can form at ground level. And our bodies are not designed to breathe ozone. Ozone starts to build up on these hot days, and it pushes out, or it removes, the regular oxygen that we need to breathe from the air, causing a suffocating effect. And this sometimes can really have a negative effect on people with asthma, or the elderly, or the very young. So air quality alerts are usually associated with very hot days. So once again, ozone in the stratosphere, good. That's where we want it. Protects us. Ozone in the lower atmosphere, bad. Could cause a lot of damage to us and also help trap in some more heat, making the planet increase in temperature. Our next atmospheric constituent are greenhouse gases. And greenhouse gases are gases that absorb long-wave infrared radiation that are given off by the Earth. These gases include carbon dioxide, water vapor, and methane. And they're naturally part of our atmosphere. They're actually a good thing. However, because of human beings' process of manufacturing, driving cars, polluting, overusing the land for agriculture, we've added more greenhouse gases than we need. And that's led to an increased warming of the planet. Basically, this is what the greenhouse effect is. Sunlight comes down to Earth and is absorbed by the Earth's surface. The Earth's surface warms up and re-radiates that heat at a longer wavelength, infrared. And that infrared gets trapped by the atmosphere, which, as I said, is a good thing. Without that, our planet would be much, much colder. We'd probably have a lot more ice. Well, because we've been making the atmosphere thicker by adding carbon dioxide and more greenhouse gases, we trap a lot more heat than is required. And that increase in heat that's being trapped warms the planet. And it's warming the planet in a trend of maybe 1 or 2 degrees over the past 10 to 15 years. And that might not sound like a big deal, but 1 or 2 degrees either way can change water into ice or ice into water, and that can have an effect on a lot of things that function on the planet that cause climate and cause weather. And as we get deeper into this topic, we will be discussing how this actually happens. So overall, of the sunlight that comes to our planet, because of the atmosphere, only 60% actually breaks through and reaches the surface. And that is the amount that actually gets absorbed and used by Earth. And then of that 60% that actually gets to the surface, only a fraction is really used on the planet. Most of it is re-radiated back into space. So only a small amount of sunlight every day that comes to Earth is really absorbed by the surface and used for Earth mechanisms. The other percentages, like the 40% that doesn't get absorbed, is just bounced back into space. Either it's bounced back by clouds, or it's absorbed by clouds, or it's reflected off of ice or water. So it's a really small amount relative to how much we get of sunlight that actually penetrates and reaches the Earth. So that's it for now, and thanks for watching.